In order to understand the basics of circuits, the first thing we're going to have to understand is how batteries themselves work. There's quite a bit of misconception about how they work, so I just want to walk you through a few examples and try and explain some things. So the first thing to understand is the battery is usually split into two terminals, and we usually call these the positive and the negative terminal. So if you pick up a battery and you look at both sides, you should notice that one of them is labeled as positive and one of them is labeled as negative. So let's assume that this here is the positive side and this is our negative side. So what that actually means, that means that if we were to kind of draw a dotted line here, that implies that anything on this half up here has less electrons, meaning you've got kind of more positive charge, and then anything down on this side, you have more electrons. So what basically happens is there's a physical barrier somewhere in the middle here that physically separates those two sides. Okay, so electrons, you have more electrons in this case in the bottom half of the battery, and you have less on the top. And there's a physical barricade in the middle, so the electrons cannot simply just travel from the negative to the positive side. It's kind of a chemical barrier, but I'll explain that in a second. So in order to allow these electrons to move from the negative terminal and get to the positive where they want to be, that's what we have to introduce what is called the circuit. We need to connect these two with some kind of conductive wire, and then we usually have something in the middle. So let's say in this case it's going to be a light bulb. So I now connect these, and we'll say this is a light bulb here. So if I connect these two, what happens now is the electrons now have the ability to leave the negative terminal, travel through this circuit, through the light bulb, and these electrons are now able to get closer to where they want to be, which is the positive terminal. So the electrons will jump over here, this side will become more negative, this side will become more positive, and then the next question becomes, well, if this electron is leaving the negative terminal, as it moves through this circuit, it's getting much closer to where it wants to be. And when an electron gets closer to where it wants to be, then it loses energy. So based on the conservation of energy, we can ask the next question. If the electron is losing energy as it moves through the circuit, and it's getting closer to where it wants to be, is that energy being destroyed? And obviously it can't be, because that would violate the conservation of energy. So we know that it must be becoming some other form. And in this case, you might be able to guess it. It basically becomes the light that shoots off and some of the heat that's going to be produced when this light bulb lights up. So as the electron goes through the circuit and loses its potential energy, it gets converted to light and a little bit of heat energy over here. So you can't create or destroy energy. Now here's the tricky part where most people don't fully understand this. When an electron gets over to this side, it's now exactly where it wants to be. But you remember I mentioned there was a barricade here. The problem is, fairly quickly, if we allow these electrons to stay right where they want to be, then this battery is going to die pretty quickly, because we're going to get to a point rapidly where you have the same number of electrons on this side and the same number on this side. And as soon as those two sides are equal, there's no reason for an electron to move through the circuit, and that battery is no longer going to be useful to us. So this is where I come back and I want to talk about this chemical barrier inside. So what's going to happen over time, I guess I'll use orange here. Over time, you are going to get these electrons that are moving through. So I'm going to have electron get over here, electron get over here. So as time goes by and these electrons move through, I'm going to wind up with more and more electrons over here. Now that's not good for our battery, because if our battery gains the same number of electrons on this side as this side, it will no longer function. And that's where this chemical barricade comes in. So what happens with this chemical barricade is there's a chemical reaction that occurs, and as a result, that chemical reaction will move these electrons across that chemical barricade. So you have kind of two chemicals inside. We'll call it like chemical A. We've got chemical A, oops, and we add chemical B to that. And why is this not working? Yeah. Lovely. Chemical A and chemical B, and that reaction between those chemicals is kind of fed by these electrons. So it detects these electrons are moving over here. That's what activates this reaction. And as a result, the electrons get moved over the other side. And let's just go ahead and say that chemical A and chemical B now form like chemical C. I am drastically oversimplifying what's happening here. But what I'll show you is that every time this chemical reaction occurs, you no longer have as much chemical A and chemical B as you had. You have a new compound, and you have these electrons that were moved over. So what's going to happen is now as these electrons are moved over, These electrons now find themselves again on this side where they don't want to be. So they'll move back through here. They'll get to this side over here. They'll say, oh, great, I'm where I want to be. And then immediately, as long as those chemicals are still present, these electrons will get moved over the other side. And this process continues and continues. So one thing to realize is the battery itself never has any more or less electrons than it started with. Whether it's dead, whether it's a fresh battery, it always has the same number of electrons. A dead battery simply occurs when, well, every time you move this electron over, as I said, the chemical A and chemical B that you need for this reaction to occur, every time it runs and moves an electron over, you have a new compound or a new chemical. So you have less of the reactants that you need. So a true dead battery occurs when you run out of the chemicals you need and you just have the product of that reaction and all the electrons have been moved. When that occurs, the electron will finally move over, and after having moved through several cycles, will basically be like, oh, this is great, go ahead, move me back over. And then all of a sudden, if there's not enough of the chemicals required, it winds up staying there. And it goes, oh, this is great, now I can be exactly where I want to be. The next electron goes through, the next electron, and eventually when you run out of these chemicals, this barricade basically can no longer function. And now you get a point where you get the same number of electrons on this side, same number of electrons on the other, and that is the point at which a battery is considered dead because it can no longer provide this voltage difference that you need in order for that to occur. So the big takeaways here are just to understand that a battery is separated into the negative and the positive terminal, and they're separated by kind of like a chemical barrier that only allows electrons to move in one direction, from the positive terminal to the negative. As electrons move through, they lose their potential energy as they get closer to where they want to be, and that energy becomes whatever, heat, light, sound if you plug it into stereo, kinetic energy if it's connected to a fan. But that energy is not being lost, it's being converted into whatever device you have plugged in. When an electron gets to the positive terminal, that chemical reaction will move those electrons back across, and that process will continue again and again and again. And a battery is considered dead not when it runs out of electrons, as many people think, but when the chemical reactants that are required to move these electrons across run out. That is the point where the battery would have to be thrown out or recharged if it's rechargeable, or something along those lines. So that's the basic idea behind how a battery works, which power a lot of the circuits we're going to be using in class. So it's important to understand what's going on.